All right, we are going to go over this power stage circuit. It's going to have a silicon carbide drive stage. I'm going to go over how I'm going to go about accomplishing a isolated to ground domain situation on FR4 with a custom laser PCB. So the whole point of this is to be able to drive a silicon carbide pulsed channel. So the input here, right here, is going to be a 24 volt input, actually up to 40 volt input. This is an LM2596, and so we come in here with our input voltage. So this is really for a coil here. It can be anything really, a light, a motor coil, whatever. But essentially the top of the coil has this connection here, and then the other side of the coil goes to here, which is the drain of the FET right here. Okay, so that accomplishes that power, and everything red on the top, that is the top layer, blue is the bottom layer, obviously. So we're going to come out of here with 12 volts. So this is all planned out. So we can do 12 volts goes into this module here, which gives us 12 in and 15 and -3 out for the gate drive voltages. So what we're going to do is, this module here is actually an isolated module, but we're not using the isolation in this. We're just keeping isolation between the drive stage and the logic domain, which is down here. So we'll get into that. That's going to be the logic domain. I'll explain more of that later. That's not done yet. But essentially, we've got the 12 volts that come in here. And so our common on this pin is going to be tied to ground. So the blue and these reds here will be stitched together. So we drill holes through and then we solder between so that we have a solid ground plane underneath all of this. That is good. So we go with our 15 volts here. See, there's a red here, but if we go blue underneath, it's also underneath. So there's going to be a via joining this. And actually what I could probably do is just pop one in here so that I know sort of where to drill. And so that is our 15 volt line that goes all the way over to this 15 volt point here on the gate drive. And then we have a capacitor from there to ground. So it goes through this pad, through to this pad, and then it will be via stitched here. So we'll stitch it there. And then same for the other side where we bring down the -3 volts here. So we stitch it here as well. I'll replace these vias, but we go here and then that comes over to the -3. So that way our gate drive can ride between 5 and -3. Then move the capacitor from there back to ground as well. So that's how we get the voltages in the way we want. So we can go up to 40 volts on this buck converter here into this, which gives us our bipolar supply, and then we route it over on the bottom layer with the vias stitching between. And you can see there's a gap here right underneath. There's nothing happening. It's nice open gap here, which is what we want. So then on the output of the gate driver, we split up into a resistor and a diode and a 10K across and a TVS. And so you can see here our Kelvin loop is nice and tight. And so the Kelvin loop, the only point that this Kelvin loop will touch is on the die of the IC, which is what you're supposed to do. And so that's cool. This is source. This will all be stitched down to the other ground plane on the bottom. And then what we also do, you can jumper if you want. You can jumper. This diode would be the snubbing diode, so this diode can go out back to your input here. But we don't really have the connections for that on here because the output here just gets routed to another section of the circuit. So that's cool. We got our new logo there, which is sweet. And what we're doing is, instead of using a TVS diode or a GDT or anything like that, what we're using here is going to be stacked neons. So we're going to stack 1.2 kilovolts worth of neons through these traces here. So everywhere there's a gap, there'll be a neon, right? So 1, 2, 3, 4, 5, 6. right? I think I have 200 volt neons. We'll see, but I can work with this, and that'll give us a cool little display as to what's going on the kickback side of things. So that's how we wrote that. And then down here, what we're going to use is we're going to use just a 5 volt SOT23 MOSFET, and then we're also going to use, because I have these, which are pretty cool. Let's bring this over. So this is the MAX 1659 IC that I have. So it's an LDO, it's 5 volts, and it gives me an on and off here, a shutdown, which is what I want, because I'm going to drive that with a push button, a latching push button, to be able to control the drive. And that's going to be pretty fun to use, because what you need to do is you have to have a separate supply here, right? Like we have our drive supply at the top, but in the bottom we have our logic supply to be like 12 volts, right? And this whole thing may be likely moving to a larger board as well, and I can show how I can make larger boards with the laser, which is pretty sweet. And that's basically all I wanted to show, because I'll move these guys over, and essentially what we're going to have is an open drain here. So there'll be 5 volts essentially sitting here, and then it'll be switched here in an open drain setup, and we can in that way actually put an LED here too if we want, and we have that IC with the connections. It'd be kind of nice. So that is a good interface. And then probably what we'll do then is, you probably remember this from an earlier video, which is version 1, which I now have working pretty good. This would be all condensed, and it would be able to fit in a smaller board. But then in that way you have one board, ideally one power supply, but right now it's just 2. One board that's capable of, driving a silicon carbide power stage, and you can do lots of cool fun experiments with that. Nice and convenient, and it doesn't have a whole lot of thermal capability. We can't push this too hard, but we can do top level heat sinks just sticking on the top here, which do help. So we're going to go with that, and yeah, you'll see that later in another video. But I just wanted to kind of go over how I have this laid out. Like most specifically this part where it looks kind of confusing, but really all it is your gate drive over here. Like that needs to be plus 15, that needs to be minus 15, and you want caps from there to ground, to your switch ground plane. So, and then you want these traces. So if I go back again to the blue here, you can see how we're via'd on the plus 15, and we go straight over, and then we're via'd on the -3, and we go straight over there. And so that gives us our nice swing. That should help with our switching. So that is about all. Another thing to note is when you're doing, like I just put lugs through here, like these are just holes that I drill, but you'll notice I made sure that there's no, I think this will all be hit out by the laser, right? When we do that. So again, we'll have the SR latch controlled push button with the onboard oscillator. This will probably be on a bigger board, and I can show how all that works, but I just wanted to go over that today, and yeah, have a good one.